You're, yeah, when you're done.
Thank you. All right. Can people hear me? I hope so. Hi, I'm John Truswell. Welcome to the MindCORE talk. I'm very happy to introduce Jessie Snedeker, who's going to be speaking today. Jessie is a professor at Harvard in the psychology department. She's very well known for her work on language development and language processing. She's particularly interested in, well, a wide range of topics, including how kids interpret speech in real time, recognizing words and parsing sentences. She's interested in how language is represented in the mind and interested in language production as well. It's really major psycholinguistic issues that she has been addressing over the last 24 years at Harvard, something like that. Hard to believe. One of the things that I should definitely mention, many people here may know this already. Of course, Jessie got her PhD here at Penn, working with Lila Gleitman and Henry Gleitman. She got her PhD in 1999. And then she stayed on for 1 more year or 1.5 years as a postdoc, working with me and with Lila. She developed some of the most important work on how kids process verbs in real time, recognizing sentences. She then went on to Harvard and did lots of great things doing work on language representation and language development. She has a very active lab with a lot of interesting grad students and postdocs that have come out of there. One thing that is really a constant in Jessie's life and research is her enthusiasm. She was probably the most enthusiastic graduate student I ever encountered, and that has not changed over the last 24 years. I distinctly remember the famous cheese seminar at the Gleitmans. I have this image in my mind. It's an evening seminar at their lovely home in Marion, and Jessie would be sitting on the floor waiting to pounce, waiting to jump up and say something about the conversation. And I've seen her do that at conferences and in person in meetings, one-on-one. She'll jump up sometimes as well. And she's very excited about all the work that she does, and it's really contagious. So it's terrific to work with Jessie and talk with her about these topics, and I'm sure you're going to see that today. Before handing it over, one other thing I want to mention, it's buy one, get one day here. We have 2 talks for the price of one. At 1:30, we will have a second talk. Roman will be speaking. Roman's right there, Roman Feynman. And Roman is a student of Jessie's, so it progresses along here. So if you have time and can stick around 1:30, and other people I'm sure will be coming in at 1:30 as well for Roman's talk. So let's have Jessie take the floor.
All right. So what John was telling you in a very kind way is that I have research ADHD. I see bright, shiny things in the periphery. I'm like, what's that? Oh, what's that? What's that? There is one thing that they have in common. I am broadly interested in understanding meaning, that thing that lurks behind language. When you say that you intended to convey a message, I want to know what that message is. It's a hard thing to study. We tend to study by looking at all of the things around it. And I typically approach it in 1 of 3 ways, looking at moment-to-moment language comprehension, a little bit of production, but mostly comprehension, by looking at language development and by looking at language emergence. If you came to hear these 2 things, I apologize. I'm not talking about them today. I'm going to be focusing really on the comprehension. And I did that for a few reasons. One is that I've come back here a couple of times since I left, but I actually have never talked about language comprehension when I've come back here, right? And it's what John and I started out doing together. But also, as I was talking to graduate students and people applying for graduate school this morning, I remembered something else, which is when I set off to go to graduate school and wrote my essays for going to graduate school, I tried to convince every faculty member that I wrote to that I wanted to study moment-to-moment language comprehension in kids, and they laughed at me. Right? They told me, that's very nice, honey, but actually we need to understand language comprehension in adults first, and we need to understand language development first. And partly I think it was a matter of tools that were available, because within a couple of years, that's exactly what I was doing. And so, this is kind of looking back at about 20 years and how far we got. So I want to make sure that we're all on the same page, and I hope not to bore you in doing that. I want to make sure that we are grounded in how we think about adult language comprehension. So when I bring up these questions and puzzles about kids, what I'm thinking and what the background for it is. And I don't like to attribute this particular model of language comprehension to any one person. I really think it's been a group activity over decades that by about the mid-90s, early 2000s got us to this place, right? And I think this is a framework that actually applies to most areas of cognitive process. We think about processing at the cognitive level, vision, auditory, language, right? As involving building a series of linked representations that involve information transmission of some kind. We believe that interpretation across these levels of representation is incremental in a way that I will soon be defining. There is cascaded processing. Processes at each of these levels are interactive. They tend to involve input from multiple other levels. And because of this, the incrementality in the interaction, we often get predictions of things that we have yet to see or hear. Let's get specific in terms of language, right? Both linguists and psychologists, anyone who studies language, recognizes there appear to be multiple representations that we're talking about when we talk about language. And in comprehension, we are building these representations up. In ordinary terms, we know that there are sounds, many different kinds of sounds, many different descriptions of sounds. There are words, there are phrases, there are ideas, and those ideas are put to the use of social goals. And we know that there are very different kinds of representational primitives that are relevant at each of these levels. So we're going to think about comprehension as involving construction at these levels, right? Moving across them. If you do not like my levels, that's totally fine. Really, nothing is going to depend on the specific levels, except a little bit when we get to syntax and semantics later, and I'll get to the ambiguity there. But you certainly probably believe that we both have sounds and meanings that are involved, right? And higher social goals. All right, so that's background, everyone agrees. Next question is, how does information travel across these different levels of representation? Well, the best thing that you can have in cognitive science is a really good fall guy of a hypothesis, a strong hypothesis that generates research that allows people to disprove it in ways that lead to better theorizing. And Fodor is perfect for putting out that kind of hypothesis. He argued for a very strong view of cognitive processing where these processes were sequential and independent of each other, that information transmission across them was encapsulated. What that looks like, if we think about these particular representations, is that processing at each level is complete before the next one begins. So that looks like this. Information goes up, gets completed, goes up to the next level. So sequential and independent. We are absolutely convinced at this point that that is not the case. On the 21st century standard model, we now recognize that processing in the timescale that we look at it is incremental. As you begin to activate phonological representations, well before, for example, a word form is complete, you're already activating words in the lexicon. Before you have settled on what the word is, you are integrating into your syntactic structure. You are making semantic interpretation of that evolving structure, and you're doing pragmatic inferences over. So incrementality that is occurring. Next, we also know at this point now that Fodor was wrong. It's not the case that each level is fed by just one level, the level immediately below it. We know that there are multiple inputs coming into many of these systems, and quite critically, that there is top-down information that is informing lower levels of representation before processing at those levels is complete. And interactivity doesn't just have to occur between two boxes that happen to be next to each other on this diagram. In fact, once we have a system where it is at least possible that multiple kinds of constraints can come into a particular process, something really exciting happens, right? When we were in a modular system, we had to organize these boxes into a strict order because only one kind of information was going into the next one. Having interactive processing allows you to consider other arrangements. For example, many people in language comprehension have argued, actually in language production too, have argued that it is not the case that lexical information simply feeds up to syntactic levels of representation before there is semantic interpretation. There may well be lexical information influencing semantic representation and syntactic representation simultaneously, and then those two levels being constrained. That becomes a possible architecture to consider when you can have multiple sorts of information going into the same box, essentially. All right, so those are the first three things. We've got levels, we've got incrementality, we have interactivity. I guess the only thing that really happened in the 21st century, this was all back in the 20th, right, was that we began to discover that incrementality and top-down processing, right, which is interactivity, actually give you pretty much for free predictive processing. Because at lower levels, when the information goes up, it is activating larger units, right? So if I get pho and I activate Florida from that, right, I'm able to predict the upcoming phonemes in the word Florida. Or if I begin to access a verb and use it for syntactic construction, semantic construction, I may begin to predict the arguments of that verb that are coming up, right? So we get prediction out of this kind of model as well. All right, that's all very cool and well, right? The task that I set myself at the beginning of graduate school, and didn't really start to engage until the end, was how does this system develop? And of course, what changed between the time that and the time we started doing this work is that Mike Tenhouse began developing the visual world paradigm, which gave us a very simple way of beginning to tap into how children were interpreting language on a moment-to-moment basis. And this actually goes back to John's early studies, that particular picture with the head-mounted eye tracker. Okay, if you don't want to go back and read 20 years of papers on this, I'll give you the kind of short version of it in the next like 5 to 10 minutes. First, mostly what we found out, right, both using this technology and using a number of other different paradigms, is that young children, let's say 3 or 4-year-olds, are shockingly similar to adults. They have similar semantic, syntactic, lexical, and phonological. And among others, has also done work showing this on the phonological side. They also engage in incremental comprehension. And there's a number of phenomena that can show that they are beginning to activate higher levels as they're getting information at lower levels. They also engage in incremental production. We haven't done much production work, but we got a cool finding a couple of years back that shows that during lexical access in production, you're already beginning, you and the young child, already beginning to do phonological encoding before you've actually settled on the meaning that you're going to encode. All right, but there is one area where kids are kind of weird, and we discovered it when we started looking at interactive processing. And this is work that I did with the following people, some of them very long ago, some of them a little bit more recently, and some of them quite recently, right? Focused on structural ambiguity resolution in kids. And this is where kids start to be a little bit different than adults, right? There's a couple other ways, but this is one. What I decided that I wanted to do is look at the absolute simplest case of syntactic ambiguity. And then I would use this as a way of trying to study how all kinds of different information could be used by a child to resolve ambiguity. I did not want to be doing relative clauses, something that was primarily literary, right? Something that children have limited experience. PP attachment ambiguities are everywhere. Oh my God, the place they really are is in undergraduate papers. Sometimes you can get like 7 PPs all lined up, and then you can start to think about all the possible parsing, right? The cool thing about prepositional phrase attachment ambiguity is while it is ubiquitous everywhere, we don't usually have a problem with it. We come up with a single interpretation quite quickly most of the time. All right, so I'm interested in cases like this. Alice attacked the paper with the weak data, where with the weak data can be attached to the paper, right? So that's an NP attachment, and Alice is our heroine. She's attacking that horrible paper, getting it out of the field. Hooray, Alice. Of course, Alice could also attack the paper using the weak data. Boo, bad Alice, right? Here it's an instrument phrase attached to the verb, or however you like to do that in your favorite syntactic theory. All right, we knew at the point when we started playing in this pool that adults use vast amount of information to resolve these ambiguities. They really care about the verb. They use that lexical information. What kinds of structures does the verb typically appear in? They care about pragmatic information. If there's 2 papers around and we're trying to figure out which one Alice might have attacked, then it makes a lot of sense to modify the paper with weak data, right? And we're likely to interpret that as a modifier. We care about prosodic boundaries. Alice attacked the paper with the weak data, right? Pushes you towards modifier. Alice attacked the paper with the weak data, pushes you towards the instrument. And they also use plausibility. Can you do that? If I say that Alice attacked the paper with the silly title, you're probably going to think of that as a modifier because it's not something you can use for attacking. So our questions were really simple empirical. What do kids do? What do they use in their ultimate interpretation? What do they use in moment to moment? And I'm going to be telling you about the results of 3 studies that were done over roughly a 20-year period, really, really quickly, because I want to tell you about new stuff. Make some new stuff fast. In these studies, we set up these sets of toys here on a little platform. John came up with this idea, poor man's eye tracking. And they would hear sentences like, feel the frog with the feather, all of our participants. Critically, in all these cases, there's going to be a target instrument, something you'll use to do the feeling if you get the verb phrase attachment. There's going to be a target animal. So that's our frog that has a feather, the only thing that's relevant on the modifier reading. And there's going to be two distractor things, a distractor instrument, a candle, and a little leopard here with a candle, the distractor animal. Sometimes that's a little frog with a candle. We'll talk about that. All right. So we varied a number of different things about these sentences, right? In our first study, we really focused on whether children could use lexical information for analysis. And what we found is that that's what they really love to do. So if you give them a verb that often appears with instrument phrases, about 90% of the time, they're going to use it and they're going to look to it within about 500 milliseconds. If you give them a verb that rarely, if ever, appears with instrument phrases, they will almost never use it to do the action, like 10, 15% of the time. And they also won't look at that target instrument very much. They'll go straight for that frog that has the feather. And if you have smooshy verbs that are in between, they'll behave smooshy and in between. All right. What we also discovered in this first study, though, is that they do not seem to use information about the context. So these blue bars here, the one referent context, we expect more responses. The red are the two referent. And across a number of studies, we almost never got a difference between those. And other people have done this as well, right? They rarely seem to use this information there to determine how to make the attachment on this particular phrase. So not using that cue. So the next thing I wondered is, I don't know, maybe they just rely solely on lexical information. Maybe they're not interactive. Maybe they can't integrate. So Sylvia Wan and I did a study where we manipulated positive these sentences. You can feel the frog with the feather. You can feel the frog with the feather. And children did a great job with this. When they got the instrument prosody, they looked over the target instrument quite quickly and they used it. Modifier prosody. Oh, sorry, that should go all the way over to that frog. All right, so our conclusion from this is that children's parsing is interactive, but they seem to fail to use the referential context, the situation, to guide their interpretation. The hypothesis I had about this, I don't know, it's probably about 15 years back, is that maybe kids are just really bad at using top-down information. What do I mean by that? Well, the reference world here, right, whether you're able to make reference, is arguably a level of representation that with respect to language and the language input is higher. It's closer to the level of intentions, communicative intentions, and interpretation. Maybe kids are really good at using lower level cues to constrain this analysis, but not the higher level ones. And one reason why this could be is you could imagine that it simply takes longer to bring top-down cues to bear. What do I mean by that? Well, if I hear the prosodic breaks, right, I get those and I can put them immediately up to the syntax. If I'm trying to evaluate two syntactic structures, one with an NP attachment, one with a PP attachment, I've got to construct those structures, send them up to higher level analysis, and then wait for that information to come back down. And let's imagine I'm just a little bit of a slower or noisier processor. Maybe that loop takes longer to finish or complete. So with that in mind, we did yet another frog, feel the frog with the feather study. In this one, we manipulated a different top-down constraint. It was the plausibility of the entire utterance. How likely is a given interpretation given the affordances of the different objects in the scene? This is top-down in the sense that you have to evaluate the semantic plausibility, so a higher level interpretation, and you have to engage in role assignment. And we pitted this against really simple lexical cues coming for the verb. Full disclosure, these were actually confounded in that first study John and I did. So in this study, we tried to pull them apart and see what adults and kids really cared about. All right, so this is really simple, actually a 3x2, but I'll show it to you as a 2x2. There's a modifier bias verb like find. It should push you towards the modifier interpretation. Instrument bias verb like tickle should push you on a statistical basis towards the verb phrase attachment. Then we have another cue that is pitted against that or consistent with it, right? We have rated these objects as being low in plausibility for the action. Find the zebra with a sponge. How do you even do that, right? Or find the zebra with a magnifying glass that has moderately high plausibility. So the plausibility of these events are matched. The plausibility of these events are matched based both upon norms with adults and a fairly simple verification study with kids. Similarly, instrument bias verb, right? Tickling with a paintbrush is of moderate plausibility. I guess paintbrushes are tickly, while tickling with a mirror, that's low plausibility, right? You're just going to end up poking if you try to do that. All right. So what do kids do with this information? What do adults do? What we learned is that adults actually do not care about the verb, right? They do ultimately in their actions, but if you collapse across the two plausibility classes, they actually show the same proportion of eye movements to that potential instrument in the modifier, for the modifier and instrument bias verbs. Verbs don't matter because what matters to them is plausibility, and they're already starting to take that into account before they even get to the prepositional phrase. So they are all about the top down in this case. Their actions ultimately show some effective verb bias, but their initial eye movements do not. Kids, opposite. Let's go back and forth, back. Right? The kids care a lot about the verb, but they do not care very much at all about the plausibility. There's a tiny plausibility effect in their ultimate actions, but in terms of their early eye movements, it's being dominated by the lexical information. So the conclusions I reached after doing this for an awfully long time are that in adults, syntactic analysis is guided by reliable top-down information like plausibility. Preschool children, syntactic analysis seems to be guided largely by bottom-up cues like lexical information, and they largely, but not entirely, ignore top-down constraints. Now, I have nothing invested about the exact age at which they begin to use some top-down constraints. You can get studies saying, oh, I can get 5-year-olds to use them, or high executive function 5-year-olds might use them. Absolutely. The conclusion that I want to draw here is that all other things being equal, these kids are much less likely to use the top-down information than adults in this context. And so that's where it was left for a while. Then, probably about 10 years ago or so, a little longer, I started to get kind of frustrated with the limits of eye tracking. So I'm going to take you on a methodological journey that's going to bring us back conceptually to this. Here's some things that frustrated me. One, when we do eye tracking, especially with kids, we have this teeny tiny little reference world, right? So we are always looking at language comprehension under one ecologically valid context, but it's only one of the many ways in which we use language. And it really limits the kinds of ambiguities we can study. They have to have referential implications that can be read fairly easily off of a scene. Next, I was getting increasingly frustrated with the idea that we had many different processes that were being collapsed onto a single measure. I can look at a duck because I think the word duck is likely to appear. I can look at a duck because I think a duck conceptually belongs in this particular sentence, right? I can look at it for many different reasons. And with eye tracking, I have just one measure that picks out the referential level, the conceptual level, right? And the lexical level as well. So I started thinking about something that I like to do, which is collecting event-related potential, so EEG, to spoken language and the potential that might have for understanding children's moment-to-moment language processing. Didn't want to look at kids reading. They don't read well. I don't think I'm going to learn something useful from that. I didn't want to use tasks where children have to do two things simultaneously. I'm looking for costs because children are lousy, right, at coordinating multiple tasks. It seemed to me that besides the visual world paradigm, this was my best bet to understand how children really understand spoken language. All right, I liked the fact that it had very fine temporal grain. If you are interested in moment-to-moment comprehension, you've got to care about this. You're not going to get the kind of information you want off of fMRI. Happy to talk more about that later. Right? You're going to get it off of EEG or MEG. I was also very attracted to it because there's a number of different components at different times in somewhat different distributions that have been argued to tap into different levels of linguistic analysis. And I wanted to be able to exploit this. We knew a lot about them from about 40 or 50 years of work with adults. However, one thing I was very concerned with is that back when I was an undergraduate and I tested people in these studies, the biggest thing we had to worry about was them falling asleep, right? Our adults would get bored, they'd fall asleep in the middle of it. I really didn't like to think about what it'd be like to put a child through a study like that. We'll come back to it. So, part 2, I'm going to tell you about some naturalistic EEG studies that we have conducted. All right, just a really quick grounding, right? EEG, electroencephalography, consists of measuring electricity at the scalp, amplifying that electricity, right? And collecting information about how it unfolds over time. Critically, in the designs that I'm going to be talking about, we want to link up this signal with particular events in the world. And we're going to be focused here. Oh, sorry, we collect it from different participants, right? But we want to link up to events in the world. So the beginning of this might be the beginning of a word. We might pull out 1,000 milliseconds linked to a word and time it accordingly. And from that, we'll get information about a particular event, right? We'll collapse across those events at different electrodes. We'll choose some electrodes or regions that we want to look at, and usually we'll end up with this waveform for a particular condition where we're interested in negativity and positivity at a set of electrodes over a particular time. So that's just generic EEG. All right, how do we usually do that? Usually what we do is we have adults come in and listen to a painfully long sequence of non sequiturs. They read or they hear one sentence, then another, then another, then another. And this goes on for about 2 hours. There's no discourse linking these sentences. There's no goal behind the sentences other than to pay attention to it and maybe give a sensicality judgment at the end, right? But no kind of ecologically valid task this links to. And like I said, people fall asleep all the time. So we decided to create 2 kinds of naturalistic EEG studies I'll be telling you, right? Following others in the literature who decide to look at full discourses. First, sometimes we just collect EEG during a story. We have someone listen to a story, a conversation, a podcast, and we continuously record EEG, and then we analyze at every word, right? We're not manipulating anything. The pros of this design, it's super fun for people. Right? They can listen to things they actually care about. It's ecologically valid. These are the kinds of things that we use language for, at least one of the kinds of things, right? And you get so much data, right? Out of about 20 minutes, you can get 2,500 content words. That's a lot of observations. Let's say your kid is wiggling, you lose 1/3 of them. Who cares? You've got a ton of data here. All right, there's obviously a disadvantage. I'm an experimentalist. Someone's accused me of having like a 2x2 mind. I have a 2x2 mind. This is correlational rather than experimental. I can never know at the end of the day whether the variables I'm measuring are really the ones that are doing it or if it's something correlated with them. All right, so we do something else. We take our beautiful stories and then we go in, we inject experiments into them, right? We take particular words and we change them. This somewhat reduces the ecological validity. You're now hearing a discourse that has some errors in it or some mispronunciations or something, right? It drastically decreases the data quantity that we get. We're down to the usual 90 or 180 observations max, but it gives us experimental control, right? Because we can hold the position of these words exactly constant and just change what's going on with them. I'm going to show you a study of each kind, a couple studies. I'll start with the naturalistic study of prediction during lexical processing. This is work conducted by Tanya Lavari, who is now. All right, so what is the measure that we're looking at here? We decided to focus on the single most reliable, most studied component in all of EEG, the N400, right? The N400 occurs in sentence context for words. It also occurs for pictures with a somewhat different distribution. I'm going to be plotting negative up because that's what EEG people do. So negative is up, positive is down. And imagine you heard a sentence like, I like my coffee with cream and sugar. I'm synchronizing to the beginning of sugar. EEG responses are never interesting in isolation. You're always looking at them in comparison to something else. So let's imagine that you have this highly predictable sentence. I like my coffee with cream and sugar. And then I did something unexpected. I'm a little bit unusual. I like my coffee with cream and honey. What you would see when you compare these sentences, this is saying, maybe we're hearing them, maybe we're seeing them, this is actually probably seeing. You would get a negative going deflection here for honey. The difference between these two would be negative going, right around here, probably peaking. All right, so that is our N400 effect, that difference, and it is argued to reflect the ease of lexical conceptual access. There have been other theories along the way. This is the theory that I think accounts for all of the data. All right, cool thing about this response is it's gradable. It's not just there or not there. It doesn't pop or not pop, right? If I gave you something really weird, like I like my coffee with cream and dog, woo, that N400 would go way up, particularly the tail flank of it in this case. All right, so you have a bigger N400 there. We know a lot about N400. We know painfully rich amount of information. First, if you take words out of the blue, right, or words at the beginning of a sentence, for adults, the N400 is going to be larger for less frequent words, right? In this context, every word will have an N400, but the less frequent ones will have a bigger one. For adults, it's also going to be larger for less predictable words. So here we are looking at words that are anomalous going down to words that are fully predictable. The N400 effect is perfectly graded in here. Gorgeous. These two things interact in a kind of way. Probably shouldn't tell you because they don't in our data, but we'll come back to that. The effect of frequency is really only appearing in those sentence initial words. As you get further into the sentence, frequency doesn't matter. And that is argued to reflect the fact that predicting the upcoming words allows you to avoid the cost of searching for low frequency words. So they become easy, even if they are low frequency. What do we know about the N400 in children? We know that they got them. We know that they're big, when there's an anomaly. So anomalous words or words that mismatch a picture produce big N400. But before we did this, there was actually no prior work on frequency, the role that prediction might play, the role that top-down constraints might play in the N400. We just saw them for semantic anomalies. So our question is really simple. The kids even show N400-like effects in the discourse. Are they sensitive to frequency and predictability? And if so, what kind of predictive cues do children use? So how do we do this? Well, we invented something called the story, where Tanya simply read a story, recorded it, right? In this case, it is a chapter from Matilda, right? So the Roald Dahl book. And we went in and recorded EEG to each word. I want to see if we can hear this. Here we go. Oh, you guys can't hear that at all. All right, we're not going to try to hear that. So what you should be hearing is her saying, Matilda's a little late to starting school. Most children begin. So from the kids' perspective, they're just listening to a story. From our perspective, we are going in and we've got a marker at every single one of these content words, and we're going off and we're storing, right, at every electrode, what the response looks like to each of these words. Okay, that gives us a lot of data points. I think it's 1,500 or so in this study. The data I'm going to show you has 27 kids in it. They're between the ages of 5 and 10. We did do a median split on these kids as well. You get the same pattern of effects. There's a set of adults that are controlled here. On this analysis, trial loss was about 35%. This is a theory-driven paper. We are not going in and looking at the entire electrical response to each word and seeing which variables account for variance. We went in with a hypothesis, right? Partly because we didn't know how noisy this data might be. We're going to look at the N400, defined as a window 350 to 550 milliseconds after the onset of the word, a little later than you might be used to if you do visual studies. That's because speech unfolds. It's slow, right? And we're going to measure its amplitude. In this initial data set, it's CZ peasy. We sometimes go a little bit wider than that, but this will be just at CZ peasy. We're expected to be larger. There's some kind of cool frontal effects we can talk about too, but we focus on those. All right, here's the fun part. We went in and we coded these words. We code them for a lot of things. Some of them are control variables, concreteness, acoustic length, that kind of thing. The ones we're going to really care about today are frequency. So log frequency of the word. We've done it in childless. We've done it in much larger adult-oriented corpora. Doesn't matter. It's all the same as far as this study goes, right? Then we've done a number of different ways of using latent semantic analysis to get some sort of lexical co-occurrence, right? Association norms. Doesn't matter, none of them. None of them do a thing for this data. So if you're worried about association, it's not playing a role. Then we did 2 measures of predictability. This was the kind of painful part. We had participants, crowdsourced participants on AMT going through and literally having to guess every single word in a section of the story. So maybe, for example, they're doing the middle third of the story. They're not, they only do about 10%, but they're doing 10% in the middle. They would read everything up to that point, right? Slowly, we force through it fairly slowly. And then they would begin guessing words. And for each word they guessed, right, they would then get feedback, what the actual word was, and then they would guess the next one, and the next one, and the next one. This gave us closed probability for every single word, right, in this story. That took a lot of time and a lot of money. We also did a version where we gave them individual sentences that were scrambled, and their job was just to guess based on the prior sentence context. Those 2 variables end up being pretty closely related. In some cases, it looks like the discourse close measure is slightly better. So that's what I'll be showing you, but I actually don't have really good ways of disentangling them. We also realized after we collected the sentence close that actually this wasn't a very good test of the information in the sentence, because guess what? When you get 30 or 40 sentences that are randomized from Matilda, you start to close in on some of the concepts of Matilda. So it's not really just sentence close. All right, so what do we got here? Well, at the end of all of these analyses and everything we did, right, controlling for the previous word, controlling for the later word, the big predictor, the only reliable predictor of the ones we cared about was discourse close value, right? So here what I am showing you, negative up, positive down, right, for the kids and the adults, is our low close words, our mid close words, and our high close words. We treat it as a continuous variable in our analysis, but this is good for looking at it. What you should see, unsurprisingly, is that adults are much faster, not faster, show a smaller N400 for very high close words. In fact, you're not seeing any negativity. That's very common. Highly predictable words really show no N400 effect. It's a drop down in the N400. The medium ones, right, show an initial effect and then it declines. And the low close ones show the biggest of all. And we see a very similar pattern in the kids. In fact, there was no interaction with any of our variables between the age group, right, and the critical predictors. All right. So our interpretation is that children are interpreting the story as they hear it. They're using this information to build a discourse model. So for example, if they're hearing something like, I like my coffee with cream and, right? They're starting to build up a model of coffee and ideas involved. And that is leading them to begin activating relevant meanings and relevant words, such that when the phonological information comes up and is compatible with those expectations, there's a reduction in the amount of processing required to recognize that word, which is manifest as a lower N400. Prediction, top-down constraint being used in kids. All right, what I can't tell you here, though, is whether this is conceptual prediction, lexical prediction, or form-based prediction, right? And if I still thought there was a viable story of the N400 where it was about semantic integration, I really couldn't rule that out with this data either, right? I think it's been ruled out pretty effectively with adults, but this data alone, I can't do it. So that brings us to studies that specifically target lexical prediction. How are we doing for time, guys? What we did first is just try to get a behavioral index of whether kids could predict words in this rich context. And this was led by Bryony Waite. She did a closed task using a cartoon that we had created for the storytime paradigm. It's a cartoon we're going to use in a few minutes when we go in and look at form-based prediction EEG. Right? So kids watch this cartoon and they occasionally guessed some of the target words. 90 of them were words that we thought would be high close based on adult ratings, 90 low close based on their ratings from written, right? Their attempt to do close values on written versions of these materials. All right, so I know already we're not going to get, well, let's see if we get audio. We're not getting audio. Okay, basically what happens is you watch this cartoon, right? It pauses, a wizard comes out. This evil bad wizard will not start this cartoon again unless you say what you think the next word is, right? And so from the kids and the adults, we get responses for the next words, and children like this. So these are 5 and 6-year-olds. We coded here, we coded a number of things, but the one that ends up being most interesting is how often did they guess the exact right word? I mean, these are kids with probably about 20,000 words in their lexicon, 10,000 words. How often are they getting the exact right word? Adults are doing so pretty well, which is good because we rated those high close words as words adults could guess, right? They're up at around 80% or so. And with the low close words, not so well. Kids are actually remarkably, they are guessing the exact right word about 60% of the time, suggesting that the top-down constraints that are here are enabling them to pick out the right word and concept. Of course, this is happening pretty slowly. They've got all the time in the world to think about it. Doesn't necessarily tell us about how prediction is unfolding in real time as you listen to somebody speak. But of course, one of the reasons why we did this is we then wanted to do an EEG study focused on form-based prediction. Again, this was Anthony and Bryony. So the N400, I told you, is a graded response. And it is not just sensitive to the degree to which, right, the word fits the semantic context or was predictable. It also is sensitive to the degree to which a word matches the form of the prediction you make. So if you're expecting, I like my coffee with cream and sugar, low N400, and you get Blicket, guess what? You're going to get a big N400 there. Possible word. But if you get sugar instead of sugar, you get a reduced. For words that, non-words that overlap in their phonological form with the word that you are predicting. So Al Kim presented data of this kind from adults, as have many others. So the argument here, sorry, we'll go back. The argument here is this reduction in the N400 is because sugar has been partly activated at a form-based level by sugar, meaning that you made that prediction. You're going to get a word all the way down to the level of form. Okay, you might have noticed something else cool that's happening. For form-similar words, we are also seeing a positivity that is later, a late positive component. And this is argued to reflect reanalysis of the error. This is cool for us for 2 reasons. One, we can look and see if false, right? But also because the fact that there's reanalysis here suggests that a lot of times you're recovering the intended meaning, right? That you're going back and saying, okay, what could this be? Which is critical, because if we're going to inject a bunch of errors into our story, you better be able to recover the meaning, or else the discourse coherence is going to fall apart really fast. All right, and the N400, again, more central, and the P600 is further back and later. All right, so the interpretation here is that you are predicting upcoming meanings based on the context that is filtering down not just to the level of words, but all the way down to the level of word forms. Now, one question that we had when we started this work was just how reliable is form-based, right? The typical study that finds form-based prediction uses word by word presentation of text. It's slow, right? You can almost feel yourself guessing what the next word is. It doesn't feel like what happens when you're speaking. Also, these typical studies that find form-based prediction use a trial-based design. There's very minimal discourse. There's just the sentence there. And because they need to have a whole bunch of highly predictable words, right? The ends of the sentences tend to consist of highly predictable words or non-words. You can start to sort of guess where the target might occur. So there's some issues here. Our studies can be radically different. Continuous speech, trial structure, rich discourse, and a real mix of predictability. So if form-based prediction is basically a laboratory party trick, we might expect it to disappear under these contexts. So first thing is just to see whether we get it in adults. And we are going to have a 2x3 design. First, we are going to have both predictable words, right? So words that are predictable in context and words that are unpredictable. Then we are going to have two types of pseudo words, highly similar ones where we just change a vowel. Cake goes to keck. We're also going to have ones that have a rhyme overlap but not initial. Here's the reasoning for that. When you are doing speech perception, right? Not written text, beginnings of words are all critical, right? If something doesn't match at the beginning, you're already recognizing that it is not your target. That's going to be a problem. This is also similar to this word, but it's a little bit further away in terms of initial cohort. We also want to use the rhymes because we were really worried that nobody would be able to recover the intended words, and therefore people wouldn't understand the discourse. And my thought was, this is kind of like Cockney rhyming slang or something. I think the kids will be able to manage it. And they were. They did largely were able to tell us what the words were when we checked with them offline. All right. So the prediction is that these are going to be the ones that show reduced N400s. All right. The reason why we're looking at both predictable and unpredictable target words is to ensure this is not a reactive effect. If this is prediction driven, we should only see the reduction in the N400 response for the predictable words, not for the non-predictable words. So it tests a basic assumption of this literature. All right, I cannot show you this. I just want to show you by putting it down here. Oh, just stop talking, guys. So what I want you to notice is that we've got 3 different lists. In one list, letters is said exactly as it should be. In another case, it's ketters, our rhyme case. And over here, it's loaders, our form similar case with the vowels change. And everybody, of course, gets all 3 conditions counterbalanced across participants. All right, here's the predictions. We expect in high close context, form similar will show N400 reduction, right? We expect that in low close context, the 2 non-words will be similar. But there's something else that we expect here that I also think is kind of cool, right? Based on our prior work, we expect that the N400 to the baseline word is going to be much lower in the high close context than in the low, because it is the prediction that is driving that down. Finally, we're going to look at this P600 region. The thought is that both of these can be reanalyzed as errors based on the original word. So in both cases, we should see a P600, but maybe especially for the high close, right, rather to the low close, because there you should be able to reanalyze it more effectively. I don't know exactly what the right theory of the P600 is, right? But if it's about reanalysis, maybe you either engage in reanalysis or succeed in it more often in high close. All right, I'm going to show you kind of a preliminary version of the adult data, but the final data is done and out there now, or almost out there. Maybe I'll put it all up so you can see it. So first thing, notice N400 lower in high predictability than low predictability. Second, notice that we get a difference in the high predictability context with a reduction in the N400 effect for our keck relative to our vape, right? We don't get that over here. Finally, notice we're getting a P600 for both of the ones in the high predictability, very strong. We're also getting a bit of a P600 here, right? Not as large, but it's primarily that N400 reduction that we are interested in. All right, and that's about to come out. What I'm next going to show you, though, is not available for anybody's consumption quite yet. It will be coming out soon. And that is, of course, we intended to do this in kids. That's why we're starting with this whole cartoon and everything, right? So I'm going to show you the data for 30 children between the ages of 5 and 6. Same stimuli, but I'm going to group the words a little bit differently. Rather than using those adult closed values from the original norming study with written sentences, I am going to break up the words into high predictability and low predictability based on the child closed values that Bryony collected in the cartoon task. So these are words that are predictable for kids. Yeah, it's messier if you don't do this. So, yeah, full acknowledgement there. All right, so what does that look like? It looks messier, but N400 here for predictable, high N400 in the baseline for unpredictable, right? Next, reduction in the N400 effect for the form similar word, suggesting that form is being predicted. No such reduction here. Is there a P600? We can't really tell, doesn't really look like it. This is interesting. Kids are much less likely to show P600 effects, and what that maps onto in terms of awareness, grammaticality, meta-linguistic, right, or reanalysis. We know kids are also poor at reanalysis. We don't quite know yet, but there's a lot of good questions to be asked. All right, so here's what I know. I know 5-year-olds make accurate lexical predictions in explicit tasks. Not as accurate adults, but pretty darn good. This results in top-down activation of word forms in real time for highly predictable words. There's some things I don't know. When does this ability first emerge? We're starting to do studies with 3-year-olds to get at this question. Hopefully in a couple of years we'll have an answer. We also don't know much about what children do when they make inaccurate predictions. They're lousy at revising syntactic misanalyses. We have lots of studies where the activation of words that are actually not the right word in context results in incorrect actions. Children seem like predictions might actually get them in trouble sometimes. So I think we have a lot to still understand about what they would do there. But that's not the mystery for today. There's really a couple of mysteries. How are we doing for time? We end at 1? Okay. Maybe one mystery you might be asking yourself, it's for adults even, forget about kids, but for everybody. How does this happen so darn fast? Right? So in our task, the speech rate is 3.25 words per minute. So that means that when I run into the word immediately before the one I'm about to predict, right, I've got about 300 milliseconds to find that word in my lexicon, have the information go up to higher levels, update, right, the representation that I have constructed, and have that information come down and begin to activate the form of the previous word. I'm still a little lost about what we should think about the speed of cognitive processing, but my gosh, to me, that seems kind of fast. We think that that's not actually what's going on here. We do not think that you are getting enough information to make that prediction immediately at the word before. In fact, we suspect that some of what goes on here is long distance prediction, I guess I'll call it, which is that you often have enough information to begin activating the correct word well before it's going to be said. So this is just a simple norming study where Anthony Iacobone went back with these materials and he asked people to guess the whole remainder of the sentence, starting 4 words before the critical site, 2 words before the critical site, 1 word before the critical site, and he coded whether the target word appeared in their continuation. And what you can see is, and these are other people's predictability materials as well. What you can see in all cases is there's actually a fair amount of information there 4 words back, right? So almost, 35% of the time or so, people are including the exact right word at that point, right? By the time you get 2 words back, they're doing it about 70% of the time. So it looks like predictions can start to form well before that critical time, which might be one of the reasons why it's possible to do all of this, right, in time to be able to identify the word. Okay, bigger mystery, our mystery for today is why are children so adept at using top-down cues to predict words in the storytime paradigm, but so darn lousy at using top-down cues for syntactic ambiguity resolution in the visual world paradigm? And I'm a very simple person, so the first thing I thought of is, don't read it, it's fine. This paradigm versus the phenomenon, right? Okay, let's at least kind of get one wedge in here. Let's do a visual world study of the same lexical stuff, and let's find out if we get prediction there, because maybe the visual world paradigm kind of messes you up with all of the small set of objects. Maybe you're like, hey, I'm fine. I'm just going to sit back and wait for bottom-up information. I don't know. It seemed plausible. So Maggie Kendall, for a number of other reasons, wanted to look at whether children use top-down constraints for lexical prediction in the visual world paradigm. And she wanted to see both, whether they could use contextual information to rule out the activation of semantically incongruent candidates when they encountered the word, and whether they could actually use this information to predict. I'm going to zip ahead and just show you the data because I want to get to this theoretical slide a little bit later. All right, so what she's looking at is a cohort effect. When you hear milk, do you look over at mitten, which overlaps phonologically, relative to a case where there is no phonological cohort member on the screen? Okay, so that's going to be one factor. Is there a phonological cohort member here or is there not? The second factor is going to be, is the sentence highly constraining? The baby drank the milk, or is the sentence unconstraining? The child took the milk. And constraint was done by manipulating many different parts of these sentences. So high constraint or low constraint sentence. Critically, there is no milk here. You may have noticed that there's no milk here. And that's because we want to rule out referentially driven looks from pulling looks away from items that have just been phonologically activated. So actually nothing on the screen is something that you would expect at the point when you encounter milk. And there was a ridiculous amount of norming that went into that. All right, so what did she find? Well, in a low constraint sentence, surprise, both adults and kids show strong cohort effects. That's just replicating, 20 years of work in psycholinguistics. In a high constraint sentence, neither the adults or children show cohort activation. This is confirming that having those referent items in the display wasn't what was driving it with adults, good. But it's also showing us that kids are crushing that cohort activation. All right, so the next thing that Maggie wanted to look at is, we're going to get through all this. There we go. Do we find evidence for activation of the phonological form earlier at the point when you make the prediction? And here we were inspired by some work that Ito had done, where in adults, she had found in high predictability sentences, you activate the word form before you run into it, as indicated by looks to things like milk when you've activated mitten, but earlier, not bottom up, predictively, okay? So she went and got those long distance closed responses like Anthony did and identified the point at which 50% of people were able to predict the word would be in the sentence, right? When you look at the kids, what you see is while we did not get evidence for cohort activation at the word, we are getting it much earlier. So this actually cuts off before the word ends, before the critical word appears, right? You're seeing activation of of milk when you expect mitten under these circumstances. So that suggests preactivation of the target's word's phonological form. All right, we rushed through that because I want to get to this theoretical test to drive me a little crazy. Preschoolers' language comprehension is really similar to adults in a lot of ways. Right? So I didn't tell you about all of them, but trust me, preschoolers are not idiots. They are far less likely, though, to use top-down information for syntactic analysis. I'm pretty convinced of that. We found it in a couple of different studies now. But other people have too. This is not just a lot of people. All right, for lexical prediction, they clearly use top-down information about as readily as adults. In none of these studies, the visual world, right, the spontaneous naturalistic EEG, the form-based prediction with EEG, in no case are we getting an interaction between child-adult and our critical manipulations. They seem to be using top-down information about as well as adults by this age. That's true even in the visual world paradigm, so it's not the paradigm. So what is it, right? Okay, I got some hypotheses. This is what I want to talk to you all about. One possibility, maybe this is about storage versus computation, right? What makes something a lexical item is that it's kind of an island of stability. It already exists. It has a form. It has a meaning. It is in memory. You've got these things sitting around. All that has to happen is for the top-down information to come and activate some of them rather than others. I mean, that's not trivial, but they're stable forms to be activated. Syntactic structure is not always stored. I'm not arguing that syntax is never stored, but you've got to be able to create new structures. And in fact, these prepositional phrase attachment ambiguities, particularly the modifier cases, almost certainly have to be constructed. So in that case, you're not selecting from something that pre-exists, right? You're evaluating options, that at least one of which has to be constructed. That might be the difference here. Maybe that's what kids are failing to do. Another thing that is kind of running around in my head is maybe, I don't want to argue that you do everything that's useful and not the things that are not useful, but I do think that utility could play a role in what processes get promoted developmentally, what innate constraints there might be, whatever, right? Or how learning works. I think there might be a difference in entropy reduction here. if I'm an adult and I have like 60,000, 180,000, you choose your favorite number of stored lexical items, and I pre-activate one. Oh my God, I've just made my life easy, right? I've ruled out vast number of things. I don't know exactly how we want to think about what pre-activation of syntax would look like. Is it pre-activation of the category? Is it pre-activation of the attachment? We could probably disagree. We could probably take a number anywhere from about 2 to 100 possibilities here, right? But it's going to be a lot fewer than over here. So maybe there's just less gain for prediction. All right. Here's something wacky that I thought of last night when I should have been sleeping. I don't know if it makes any sense. Remember I was telling you how we get to move these boxes around once we're willing to consider multiple sources of information going into the same process? Here's the bottom-up connections. Well, what if there are two different top-down pathways? One of them might happen very quickly, right? Maybe by pragmatics to semantics and lexicon to phonology pathway is easy. Green is easy here. Maybe my pathway from semantics to syntax from pragmatics, maybe that develops kind of late. It's not totally clear during comprehension what I would need this pathway for. I, at the last minute, decided to color this arrow green because I think there's lots of good reasons to think that syntax constrains the lexicon, like things like, grammatical gender effects, but we could talk more about that. Maybe that could distort its unit too. So I think that's possible, right? That it's something about the complexity of this that leaves one pathway to happen before the other, or maybe that's to do with where syntax is. There have certainly been people in psycholinguistics who argue that during comprehension, syntax gets involved more often when you're engaging in a comprehension through production kind of pathway. I don't know that I believe that, but it's been argued. All right. I wonder also if prediction in the syntactic domain tends to be different, right? So back in the day when I was here, it was one common thread between the computer scientists and the psychologists and many of the linguists who were at Penn at that time was an interest in LTAG, right? Tag grammars, the lexical storage of structure. Whatever your favorite theory of that is, it's clear that when you are accessing words, you often have to access things that are systematically linked to structure, either semantically or syntactically, right? Maybe what typically happens in syntax is our prediction is largely bottom up. We recognize the verb and we pull out the verb argument structure and something about the syntactic form of that, right? If that's the case, it might be that kids have difficulty with the top down because they're largely using the bottom up route for prediction. This is grasping at straws, but I can only think of one case where lexical prediction is driven bottom up. And that is the and case in English. I'm sure there's ones in other languages. This is not grammatical gender, right? But when you hear the you can predict that you're going to get a consonant. When you hear the and, you can predict that you're going to get a vowel next. All right. This has turned out to be one of the predictions that people are really lousy at. There's a whole EEG literature trying to chase down whether they do this at all, right? And some people arguing that it's a false positive that's out there, many people not being able to replicate it in adults. We know kids are really bad at this, right? So there's a preferential looking study by Gamby that shows that children are really bad. Here, arguably, you're taking information, lexical information, you're activating potentially, right, the form of the word. You could do that. Kids are failing at it. So maybe we like to have our prediction going consistently in one direction. I don't know. Of course, there's a really simple explanation, which is just that I have not managed to make the studies parallel enough. And if I can think of syntactic cases that are parallel to the lexical case, everything will fall into place. I haven't been able to figure out how to do that. So if any of you have great ideas for how to do that, want to work on this or want to inspire me or want to do it yourself, I'd be dying to hear that because it could be this is just trivial and I haven't figured it out yet. All right. I want to thank you. I want to thank the people who funded this, and I'm eager to hear your questions. Yes.
To using identify and both the target and the structures, and would actually make two. Sort of like making the target, for example, the two attachment sites, both of those very salient people, I would guess people sort of like, instead of constructing those two structures again and again from scratch, they would have sort of a heuristic or pre-stored template for both the distract and target, and under the storage versus computation hypothesis that would literally make facilitate top-down processing.
Yeah.
The other one is like the entropy reduction even less.
Yeah.
The people's behavior would change or is different compared to other.
Yeah. So a couple of thoughts about that, because I've thought about that too. And let me tell you what makes it complicated. So I don't think it's what you're saying, just in case anyone else didn't get this. We're not talking about whether syntactic priming can occur, right? And whether that might bias you syntactic, because that would all be within our little syntax module potentially, right? So that wouldn't be top-down processing. You're saying, wait, what if you basically got a situation where you were thinking about two structures, thinking about them a lot, you have them already constructed, maybe with some lexical holes in them still, because presumably our items aren't exactly the same. And then if it is that, and then you somehow bias them with pragmatic information, and you see whether they are more likely to use that, given that those two structures have become salient. Absolutely. You can argue that's what's happening for adults in this situation. I think it's very salient to them what the structures are quite often, or the alternatives, right? With kids, I can go back and look at my data, and it's not going to help us there, because it turns out what the kids do is perseverate like all get out on whatever interpretation they had first, right? So you're not getting better over the course of study, but I don't usually switch them too often. So I don't necessarily have the data that you're looking for there. I will say I have another concern about that, right? Because remember how I told you I'm pretty happy with a heterogeneous lexicon, where I might store in my lexicon syntactic chunks. I think one worry I would have about that, right, is that this would push you to a more lexicalized version, where maybe you're pulling them out, because I'm already saying that you often access syntactic structure and get predictions, right, off of a word. Because otherwise, I've clearly got evidence that there's predictive syntax. I have to be driving off the meaning if I wasn't doing it that way. So that would be top down. There's another possibility, right? Another possibility is that I am blinded by my theoretical preconceptions, and I'm overlooking the phenomena that is top-down information. I'm giving it a lexical attribution when really I should be giving it a semantic attribution, and it is coming top-down. I worry about that a lot. But yes, I do think you're right that you could get it something like that. The other thing I've been playing around with, but I haven't turned into experiment, is it seems to me that if we're talking about syntactic prediction, it's a little bit simplistic, but we're probably going to be looking at functional items, right? We're probably going to be looking at closed class words, because I want to rule out the possibility of lexical prediction, right? So I don't want to be looking for a specific verb or a specific noun, because yes, I'm going to find out there's lexical prediction. And so I've been trying to think a little bit about that, right? The constraints that would heavily push you. I think the best bet right now might be to really focus on question under discussion manipulations, right? Because it just seems like the most powerful thing that could push you to expect a certain kind of answer. Yeah. Thanks. John.
I'd like to learn a little bit more about an alternative explanation of the EG findings. That it's not the reduction in the N format effect. When the form is slightly different from the second word, that's actually not a top-down effect, but rather an integration effect. I mean, we can talk about this a little bit, but I think we could sort of, if it's the case that this really is a top effect, then there isn't really a conflict, right? So that there's simply.
So we can talk about what happens. In the broader adult literature, we have that N400 effects, particularly within this relatively early window, and for speech, I'm still in the relatively early window, that they are not well predicted by the degree of semantic fit or integration. They're better predicted by closed probability in that direction rather than how does this concept fit. Next, I think that the Al-Kim style findings are findings that you get form-based reduction, right? Are most consistent with there being form-based prediction, particularly that form-based reduction for that highly predicted, right? So those are two of the things that I We do not have we do not have word by word ratings of how easy or hard it is to integrate the words, right, in our code story. It's gonna be negative, but it seems like it could be useful. What you use what you have, like part of the value of the story now is how things have been worked across. What else? I just want to notice is just how early we are seeing these facts. And fact, unpredictable, perfectly good words is bad for kids as long words. That's not unusual. That no prediction words actually be bad as bad words. So I think many of us have been misled by what we have seen in EEG literature, right? That initially we saw people's violations, expected violations to be much worse. And how I showed you on the data with idealized, where the violent, that's semantic as a later effect was pulled away. That's really common. Maybe that's another thing. I believe that what you call the N400 is a little bit fluid, and it's certainly the case that all negativity throughout very prolonged window is not going to be the same thing, right? What we see in all of our data sets is crazy to come. So another study that's kind of similar is that we did a study. We're calling it a code switching study. We don't have to think about that way. We've got very fluid bilinguals. We have an English text. You're getting a word that is either translation equivalent, right, or the predicted words, so high predictability words, or one that is a little bit weird semantically, right? And what we get is that all three of the non-predictive conditions move identically from about 200 milliseconds to about 450 milliseconds, right? Consistent with the idea that we produce a very specific word form. Then what we see is a semantic integration of that, one that fits, right? And then later do we see it, it's actually specific to language. So I think that also is probably consistent with this prediction of the form story.
Oh. Yeah. Next happens to chat in a room, but maybe
Just say, I'm going to find Mark. I'm going to try to unmute him. I think I have the power. I don't know if we're getting any audio off my computer. I'm so sorry, Mark.
Okay. So
hi, can you hear me?
Thinking about possible differences between the eye tracking referential world studies and those studies. Studies actually leads on the top down, right? Because it seems to me that in the studies, the key and the has the construct. What is at stake, right? You need to investigate with finding the right reference, and therefore the need to add a modifier, and that may be why. So it is as when we see question under discussion, and we know that for kids this can be a difficult proposition. Whereas historic comprehension, you don't have to discover that, so to speak, right? All constructed from the world, but the story itself makes it right you get out of the predictions. It doesn't depend on free inferentially uncovering this question of discussion.
Absolutely. And there's one of the reasons why it's so important to me to find another top-down cue to look at, right? There's a lot of reasons why figuring out an modifier in the two reference contexts is needed would be difficult. Right? It's got to actually be the right modifier among other things. There's all the work that Sarah documented and like Karen Hostage on the correlation there. Pretty neat. There's a lot of ways to get around it.